Alright, in the last video we answered how much to order. Right? Now it remains another question to be answered. It is when to order. Right? The question remains when to order. Like, do we wait till all the inventory we have in hand is gone to order? When do we order? To answer this question, we need to define few terms. Let's start with the first is what we call inventory position. Inventory position. It is exactly as it sounds. It's the amount of inventory on hand. It's the amount of inventory on hand. Amount of inventory on hand plus the amount of inventory on order. Right? But for the most scenario, so let me write this actual definition. And so the first part is obvious, the amount of inventory we have, amount of inventory on hand. So the second part is very certain scenarios this comes into play. The scenario is you have a huge lead time and you already placed an order and the inventory is on its way. We count it under our inventory position. But for the most cases, this part doesn't really come into play. Well, this defines us, this takes us to another term we need to understand, what we call the lead time. Lead time is really the delivery time. Right? It's a delivery time. You place an order today, how long does it take for a supplier to deliver the product? That's what we call lead time. Alright, now last definition I promise is reorder point. So reorder point really is the inventory position at which a new order should be placed. A new order should be placed. Okay. Now, so now this should let's look at this diagram that I drew earlier. So suppose we start with some inventory, it goes down. So this is the inventory. This is the Q star order quantity. You order that much inventory. Over time, it slowly starts decreasing, and at one point, it becomes zero. So ideally, we want our next order to arrive here, right? So our inventory again, the order arrives. So we place an order for Q star again. So again, we have this much inventory. Again, we start to consume it, and at some point, it becomes zero. Again, ideally, we want the next order to arrive right here. So the idea is for the next load to arrive at this point, when should we place the order? Well, ideally, this gap is what we had called earlier the lead time, right? So we place an order here if this is the lead time, and voila, the load arrives exactly when our inventory is done, right? So with that thing in mind, let's define a formula. Let's call this the reorder point is when, suppose our daily demand, because the lead time is usually expressed in daily days. So this is the demand per day, and this is your lead time. Okay, lead time expressed in days. So this is your lead time in days, and this is your demand in days. So that's what makes sense, right? So if you know your lead time is say 2 days, and if your daily demand is say 100, then you place your order when your inventory position is at 2 times 100, that is 200, right? Let's do the problem for our problem at hand. So what our big D, our demand for the whole year, was 104, right? Suppose for the sake of argument, there are 250 working days. 250 working days that the business is open, right? If that is the case, our daily demand is 416 cases per day, right? If your daily demand is 416 per day, and suppose the lead time, call M, is 2 days, then our reorder point is this demand per day, that is 416, times your lead times of 2, so 832 cases. That means as soon as our inventory position hits 832, we should place an order. How big an order? We already calculated that. That was our Q star, which was 1824. There's one more thing which it should be obvious, but let me point that out. Sometimes we use a term called cycle time, right? So that is on what gap? What's the gap between two consecutive orders? We want to find that, right? It's the time between two consecutive orders. Time between two consecutive orders. So there are many ways to find this particular value, but let me go about finding in a roundabout way. So we know our annual demand is 104,000. This is our capital D. We know our Q star, our optimal economic order quantity, is 1824. That means in a year we place an order. How many orders do we place? So we have 104,000 cases of demand, 1824 every time, so it comes out to be about 57. So we place 57 orders. So given that we have 250 working days, and we know we have to place 57 orders, that means on average we place an order every 4.39 days. Well, there is another way of finding this too, because we know our daily demand is 416 cases. Our daily demand is 416 cases. We place an order of, every time we place an order of 1824, that means 1824 divided by 416. This would last about 4.39 days. Right? But I like this way of thinking. This way of thinking is, you place 57 orders per year, right? That means, and if there are 250 days available, your orders should last for 4.39 days. So on average, you order every 4.39 days. So to wrap this up, what did we do is, we figured out a formula to decide what is the optimal order quantity, so that your holding cost is equal to your ordering cost. Right? Then we said, well, we know the optimal amount you should order every time, but when do we order? Well, we figured out when the reorder point, what we called reorder point, we figured out this by saying, okay, I know what my daily demand is, I know how long it takes for my order to arrive. That's what we call the lead time. Using that, we figured out when should we place an order. Then we define another new term called cycle time. That is really what is the gap between two consecutive orders. Okay.